Hello there. Today we'll be doing our last medium question in a linked list, and we will be moving on to trees next. This is going to be LRU cache, and this will be our 58th problem. In LRU cache, we're trying to design a data structure that consists of the least recently used. So that means that we will have a capacity here of 2. And we want to put items in. If we get items that are of the most recent 2, that means we can get them. If we put more than 2, then we will lose the least recently used one. In this case, the 2 was evicted. And 2 was not found. The reason that is because we got the 1 earlier, and now we get the 2 and was not found. Then we then we put the 4 in and we evict the 1. And we try to get the 1, it's not found. We return -1. And when we try to get 3 and 4, it is found. So the way to do this, you would think it would be to store in a array, and that would work, but it would be O of n, and we cannot do that. We're trying to get an O of 1, average time complexity. So that means it's a hash, but a hash does not have order, and the only way to get order and to make an O of 1 operation is to use a linked list. So we're going to be using a linked list and hash map to do this. The thing is, we want to be able to point to the last items and the first item, so we can attach that to the head, as well as pull things out when it is when we no longer need it. We want to move those things out when we see it and put it back in the front when we get the item, wherever it is, and we want to put items in and move that out whenever we see that, where it's in the middle. So yeah, and so we're gonna create a class called node, and in this class we're gonna define an init function, and in this init function we're going to need a key and a value. The reason why we want a key and a value in our node class is because our hash set points to the node, which holds the information about the next node and the previous node, as well as the key and the value. The value we can return, the key we can use to either remove or add to the end of a list, so that we can make operations more easy. So let's set it. Self.key equals key, and self.val equals val. Now we're going to set self.next is equal to none, and self.prev, the previous item, to none. Alright, with that set, let's set self.capacity equals capacity, so we know where we're at. We don't have to worry about like the current capacity because we have a set, a hash set, that will do our job for us. So it's a dictionary that will hold our items, and we can get the length of that hash set, how many items in that hash set, and then match it to the capacity. I think it's an O of 1 operation, should be fine. Okay, so then we also need our head and tail pointer. The head and tail pointer is the way we will identify where where the item is in our list, whether it's at the head or at the tail. I think we will be pushing things out. We'll be adding things to the tail and pulling things out from the head. Yeah, I think that's how we should do it. But anyways, let's get going. So head equals node of 0, 0, and self.tail equals node 0, 0. So self.head.next is equals self.tail, and self.tail.prev is equal to self.head. So what that does is that it sets our head to point to tail, and tail to point back at head. So now if we insert anything, we will insert it in between these items. So it kind of knows where to go. Okay, so let's set up our get function. When we are getting items, we are looking to remove the item from linked list and adding the item to tail of linked list. So that and then returning the value. So that means we need a add function, and we also need a remove function, because that's how we will remove the item from the linked list and add it back in. We don't need to do anything if the key is in the hash set, the self.hash set, then we will perform this operation. Otherwise, we will just remove the hash set of the key. That will remove that particular node, and we can add that node back. Hash set of the key. We'll add that node back to the beginning of our linked list, and then we will return hash set key dot val. Right, and then I think we can just otherwise return -1. Is there anything else that I'm missing here? No, I think that's it. So that's the 3 things that I needed to do. So let's set these functions then. So looks like I need to remove the node, add the node and remove the node. So let's get the node, and to add the node, we're gonna add it to the tail. So let's say the last node is equal to tail.prev, so the previous node, and last node dot next is equal to node, the current node, and node dot prev is equal to last node. So what happened was, basically the image is, we had a last node here, we were pointing to tail, right? Now what we did was no longer, the tail is still pointing to the last node, but the last node is now pointing to our node, and the node is pointing to the last node. So the last thing to do is to set our tail to point to node. So tail.prev is now equal to node. So tail is now pointing to node, and node needs to point back at the tail. So node dot next equals tail, and that's it. That's we have completed the add function there. So with that done, we can do the remove function. We'll just have to remove it wherever it is. So node next equals node dot next, and node prev is equal to node dot prev. So what that means is, basically, here's a node, here's the previous, and here's the next item. They're pointing to each other. So what happens is that we're gonna take node prev and point it equals node next, and a node next prev equals to node prev. And so what basically that does is we're moving this n from this operation, and this is no longer pointing to n. So p is now pointing to next node, and next node is pointing back at p. what happens to n is that it's still pointing at these two items, but that doesn't matter anymore because nothing's pointing to node, so it's been released from memory. And that is how we do remove. Once that is done, we can this basically does the removal process, and yeah, that's it. Done. Okay, great. So next item is that we're gonna do the put. The put option is basically we're gonna put something in, and so if the let's differentiate the situations that happen. If the item is already in the key is in this key in the hash set, what happens is that we just need to remove it and add it back in later, wherever it is. So remove. We need to remove it from our hash set. Why? Well, the reason we need to remove it from our linked list is because we will no longer be pointing at it anymore. We do not. It is a new location at the list, and the location is at the end of the list because it has been accessed. So self. So the node is equal to node of key and value, and we're gonna add that node to our linked list at the end, at the tail, and then we're gonna self.hash set at key is equal to the new node. This new node has all the information that tells us that it is at the end of our list. This is the most recently used item. And so if our length of the hash set of is greater than our capacity at this point, this is basically if we did not remove anything, we kept on adding, eventually we'll be over capacity. What will happen is that self.remove head.next, which is our this is our least recently used item, and I think that's it. That should be all. Wait, one more thing. So we have to delete the self.hash set of the head.next. But the problem with that is that we can't delete it because head.next is already gone. So we can delete it from head.next first from our hash set, and then we can remove it from our linked list. I think that would work. Let's see. Let's run the code. Self.tail. Next. What happened here? Last node.next. None type. So it was pointing at none. Oh. Hash set is not defined. Capacity is not found. Hash set is not defined. head.next. Key era. Oh wow, and we have solved it. Beautiful. So let's just remove some of these comments so that we can get everything on one page. Hopefully. This is a lot of code. We tried to shrink it as much as possible. And I think that is as much code as I can. Let's see. Let's try. How's that? I think that's it. That's everything. That's all the code for this particular problem. We shrunk it down as much as possible because yes, you can set this as a node, and then it'll be a little bit easier to see, as well as this, and as well as this one. But in order to save code, I guess this is the way to do it. Otherwise, we could have done this. So we could have copied this and set it to node equals self.hash.next, and then we could remove that node.key, and we could also remove the node like this. I think that would work. So submit. Yeah, that did work. So that way it's a little bit more clear about what's going on. But a wonderful problem, very good way to work on our linked list and think about it, and think about how we can use it in conjunction with a hash set, so that we can get one way of handling a list of items that has order in O1 operation. This is great stuff. I hope that you do this problem yourself and do it multiple times so that you can get the full understanding about what's going on here. And I hope you enjoyed the video. Please like and subscribe, and if you want more videos, check the link in the description below. I think that's all. Thank you very much. I'll see you in the next one.